Alright, welcome back to another episode of our OpenSuspect coding stream, and I think everything is working. So what's going on here? So there have been some progress made in the last few weeks. There are of course many of the issues we still have to finish, I guess. For the beta version there are 2 pull requests that should, once accepted and merged, should finally finalize the alpha version. And once the alpha version is finalized, I want to promote the project on the internet to the Linux and free software folks, because we just need more people to review pull requests. We need people to test these, find issues, find things they don't like in the implementation, because the people I've been working together on this project are not working on this project anymore with the required, I guess, not enthusiasm, but the kind of, they don't have the time to put in that we would need to progress. And as you could see, in the last few months I barely worked on this project. I worked on other things instead, because I just cannot have like 5 pull requests of mine sit there unreviewed. So what are we going to do here? I'm teasing you with pulling this thing here. We are going to be making our character animated, because at the moment, let's put this to full screen here. So if I get into the game, this is how we move. We're just skating through the map, and well, spoiler alert, we have almost everything here. So I added a few things. So originally there was no acceleration and deceleration, so I added some acceleration and deceleration to our player, so the movement does not start and finish abruptly. This is not really how things look like in multiplayer, because we'll still only syncing positions. That will be something I will have to end up doing, which is on our issue list, and that is of course well, animate characters is also on the list, but we also have I don't know, is this part of the animate characters thing? I'm not sure. Anyways, I want to do some kind of the prediction, client-side prediction thing, where we don't just sync the current positions of the players like 5 or 10 times a second, but instead we also sync their movements, and so the client will also try to predict where the character should be in the meantime. Anyways, that will be something else. Now we just have to focus on our skeleton here. So we need to animate the skeleton. Currently what I can do is I can grab these bones and move, okay, not the sprite itself, but if I grab these bones have an effect on the sprite, which is good, which is exactly what we want. So this way I can move my toe, even though I don't have to have all these different. So we have, like, the pants are separate, I guess, from the t-shirts and stuff like that, but in any case, the thing is, by moving the skeleton or parts of the skeleton, we are actually kind of moving things. So what I want to do, I want to animate this, so maybe I want some kind of the toe going up and down a bit. We can also, of course, rotate these things. So you could like make the character just a bit, like tap its toe while idle. Something along these lines. Well, the good thing with skeletons is we can go to the skeleton and we can how to reset this. So what? The skeleton has like a rest pose. Oh, reset to rest pose. So even if I, you know, go crazy here and move things around, I can always go back to the skeleton, on the left side of your skeleton, reset to rest pose. Okay. So that is kind of important that we can play around with this. So I want to animate the skeleton, so I will add a child node here now, and this will be the I will be using the animation tree node to be used for advanced animation transitions in an animation player. So first we need the animation player, container, and player of animation resources. So let's just add it to our skeleton. Let's move this up to the, I don't know, just below or above the skeleton itself. It's very fine that we name this skeleton and also the skeleton. Anyways, animation player. I don't think we need another name for the animation player that can be called animation player. And now, reset on what? Reset on save. This is used by the editor. Set to true, the scene will be saved with the effects of the reset animation applied as if it had been set to time 0, then reverted after saving. What? In other words, the saved scene file will contain the default poses defined by the rest animation. Okay, so that is good. Alright. What we need to do is we need to create a new animation for our like idle state. So I want my character, maybe, you know, we could make it like bob its head. That looks silly, but anyways, well, maybe, you know, like tap the toes, give some small movement to our shoulders here, something along these lines. And what we can actually create a pose now that we are in the animation thing here. So if I go back skeleton, reset pose. So location, rotation, and scale. So we won't change scales. Insert key. Record. Auto insert keys and objects are translated, rotated on scale. Keys are only added to existing tracks. No new tracks will be created. Key must be inserted manually for the first time. Insert key, insert existing tracks. Copy pose, clear pose. Alright. What should I do here first? Okay, so what I want is a very like casual movement of the arms. Just, you know, like back and forth a little. Now this one, if I select this as the right shoulder, yeah, we don't want to be excessive. Like, I know this game is located in Germany, but not this Germany. All right. I am being very silly here. So let's go back to the reset, or let's reset our pose here. Maybe, you know, in the future I will have to have like the longer arms, or maybe I should just... Whoa, where have I gone? So this is kind of... Hey, what? Oh, sorry. I should be working with the shoulder here. So, because I kinda... So the sprite is a little short. And this shoulder is a little too high. But I think it is already too late for that. Because if I wanted to go back to my... So the shoulder, and we can... Where do I deal with the skeleton related things? Maybe that's related to the sprite, yeah. So polygon 2D and skeleton options. No. Use snap, what? Rotate mode, scale mode. So this, yeah, these are the UV things here, yeah. Points, polygons, bones. So here we have left, right shoulder here and here, I guess. And then right arm, right hand. These are for the deformation, I guess, of the sprite. Well, I could still move this probably a little. So because you can see that if I move this sprite, well, this actually moves the whole sprite because everything else moves with it. But if I move this part here, you can see that okay, that might not even be, okay, so that might not be a problem actually. So let's go skeleton, reset, rest pose. So maybe I can actually transform this right shoulder, maybe move it a little. Not to the up, but I guess 180. What was this? 220. So maybe I will do just 200, and then this one I will raise by... Oh. Can I override the rest pose now? Yeah, and you can see now we are in the same situation. And actually this shoulder was already 200. Okay. This is interesting. Why is this hand longer? Let me hide body clothes here. These two are very different from each other, which is not good. Okay, so before we do any animations, we'll have to clean this skeleton up. Anyways, we need to do this, and let's take a look at our UV for this one, and then the UV for the left arm, which is of course in... Okay, so let me just close this so I can scroll through these things more easily. Can we have both of these selected at the same time? Yeah, but then I cannot take a look at the UV. Yeah, so this is actually not the correct position. I'm afraid that the correct way to do it is more close on the left arm. And left hand, left arm, left shoulder. Yeah, because the left shoulder, this... I think we can even move this a little more to the bottom. I guess I can select the left shoulder and put it minus 180, and then this one can go to like 70 or something. And now if I hide the body and the clothes, and I'll rotate this arm. Well, I guess I have to like overwrite the rest pose here, yeah. First, okay, so that was what I was missing. Yeah, this looks much more reasonable to me. Minus 180 and 70. Minus 180. And let's overwrite the rest pose here. Yeah, now I think the two hands are symmetric, so that is good. So now if I dress up my character here one more time and start waving the hand. Well, yeah, it's much better. It is much better than it was originally, so let's overwrite our skeleton here. Overwrite the rest pose, and now we can start animating it. So, today's stream's goal is at least to have an idle animation, like a little waving of the hands, but not too much, so I don't want the guy to go like this while idle. Like, you don't need to do like the shoulder stretching exercises in this game, but at least something should happen. Like, the character shouldn't just stay totally still, so maybe we can, you know, like rotate. Oh, this is not a good idea to rotate the hand. Maybe if I rotate here, yeah, maybe we should just leave this alone and maybe there can be some rotation in the, what is this? The knee, not knee. What do you call the knee on your arm? Elbow. Your arm knee. Maybe I should actually... So let's take a look at the UV here once more. Shoulder, no, right shoulder, right arm. Yeah, we could maybe move the right arm down a little more. So the upper arm and the lower part of the arm is a little more in sync with each other. So let's try to do that. So while these things were not animated, these did not pose any problems. So that goes down to 90 and this goes down to, I guess, 55. And let's overwrite the rest pose. Great, and the same should be here. So this is 70, so this also, okay, this is also 70. Or what? 75, 75. So what am I missing here? 180, 180, that's same. 70 and 70. Did I not do anything here? Not 50, I want 9. Okay, was this 90 before? No, I make it 90 and make it 55. Oh, maybe I clicked the wrong thing over there. I should overwrite rest pose, yes. And now if I rotate this, yeah, now the sprite is not good. I mean, it's not that bad actually. So if we don't, like, you don't want this to rotate in negative direction because your elbow does not rotate that way. So it only rotates this way. And it's almost good. So let's go back to our UV here. How do I paint this? Maybe we should have okay, so clicking on these is not easy. Does this make any sense now? Oh, I could just reduce the radius here. What? No, this is not the radius. What is this? I'm not sure. Anyways, maybe we need to move these points a little lower. Can we do that? Is it possible to move it right now? Points. Create internal vertex, create polygon, remove internal vertex, rotate polygon, move polygon. So if it's like move polygon, what can I... Oh no, this will move everything. No, cancel everything. Oh, what have I done? I moved the polygon and I have no idea how to move it back. Ugh. Okay. Let's not panic. I'm totally panicked. How can I just save this, close this, and reset it from Git? Yeah, so we have no, everything is in this same thing, and I need to find out. So I deleted some things that were already in this skeleton because we had some leftovers in this from our previous iteration of the game that we don't need, which I deleted, which is this is why we have so many red things here. And this is something that also changed. And I think, what is this? How do I revert this? Yeah, I don't think I can revert this, can I? I have to revert everything. And okay, so now I know exactly what I want. And I will do it better. So let's go back to game, character, and well, we can open the skeleton from here. And what we want to do is actually just put the skeleton part. This will go to 1 minus 80. This will go to 70. Minus 80. This will go to 70. And then we'll do the skeleton overwrite rest pose. Yeah, so this was good for that, and then this is where we still have some problems. So yeah, this one goes, this is okay, so this one goes 55 and this one becomes 90, and same here, this one becomes 90 and this one becomes 55, and then the skeleton overwrite rest pose. And now we're talking. So let's reset to rest pose. I will remove the animation thing from here. And these things are... I left these in because I was hoping that I can use the old implementation of the animations in this, but I cannot, so I can delete this. So I will just save this as it is now, and so you can see that these are all the things that I deleted. That's not a problem. Let's just hit add. So anytime we modify anything, we can come back to this state here, which is the goal. So what I want is, I want to modify the UV here just a little bit, because having like the right shoulder have the effect on there, that's good. But these points, how do I zoom in? Control, I don't know. I just have no idea how this works. Polygons, points, I want the points. Move points, can I snap grid? We're not really on the grid here, right? Yeah. Can I edit? No. So now what I can do is... Wait, nothing has changed yet? Oh, because I haven't saved it. Oh, but I can Control Z here. Oh no, I could just Control Z in the editor all along. I'm not sure. Polygon has internal vertices, so it can no longer be edited from viewport. Okay, that's fine. So I can technically move... Can I move multiple points? No, I have to move them one by one. And if I turn on the snapping, things will look very weird. How did I do this originally? These are not... Why aren't these snapped properly? I'm not sure, but maybe we can alleviate that. Maybe I was copying this from somewhere. What will happen if I change all these points? Will these affect my skeleton? That's the important question here, because if it does not affect the skeleton, it's perfectly fine to refine these points. But now that I know that I can just, I have like a save point where I can go back, not that worried anymore about this. So I guess this is What we can do here is just move these points around a little bit. Move this a little more to the bottom. Maybe we can do this. And move these points closer here to the sleeve. Like this. Okay, so maybe, I don't know, this looks fine for me. Bones, right shoulder, right arm. So I think these points should be affected by the right arm 100%, and the right arm we can remove these two here and go back, and now I guess maybe I have to go and make the skeleton override the rest pose, because this is now distorted. This is now distorted. Oh no. How do I reset this? Edit. Clear UV grid settings. No, I don't care about those. The UV, okay, so points. Can I copy polygon to UV? Alright. Oh, okay, that was the issue. So this is not distorted anymore. Oh, what am I doing? No, I should be selecting now this bone here. Yeah, okay, I can see what the problem is here, so go back skeleton, reset. So we still have some problems with the UV points here, so I guess we have to let this bone to affect these points too. Well, I guess, yeah, I guess it has to. Yeah, I think if we don't really need like to bend the arms more than like a few degrees here, so I think that is perfectly fine. Of course, for the other arm we need to do the same, I guess. Yeah, like you can see the difference. The difference is well, it's a big difference. It's much better to have so 15.9, so let's have this same rotation. Oh, it's almost the same rotation. You can see this is much better. So even if I just move it a little, like 26, let's move this to like 26 too. Yeah, it's better because it does not bend the upper part, which the left hand does. So let's reset this, and let's take a look at our left arm polygon here. So this is also not okay. Again, this is also not on the grid. I wish I could see both of them at the same time, so I have a reference how I did it on the other one, because now this won't be the same, which I guess is not that important. It's not that super important because this is the left arm and this will not be visible that much as the right hand, I guess, because this is just behind the body. Anyways, let's try to put everything here also on the what is this, grid. And what we need to do is edit copy UV to polygon. No, copy polygon to UV. And then bones, we go to left shoulder, and this is fine. I guess we made those to purple yellow, and this is the same. And now, if I select my bone here, it's still bad. Why are you still bad? Okay, let me take a look at this UV. So you put the points right above the second, like, what is it, the black line, 1 and 2, and then 2 and 1 and 2 distance. And this just runs right next to the bone, and the other side it's almost outside. Okay. So I wish if anyone in the chat knows how to copy this to the, or how to have the reference. It's not that bad, actually. Okay, so that is the problem here. That we need to move every point down by 1, I guess. So every point will be moved down 1 vertex. I guess these have to be moved to the outside one. Just a tiny bit. And because when I take a look at the bones, I mean, I guess the bones are not at the same exact position, but we can move the bone a little, I guess. And it copy polygon to UV. Yeah, the bone is not exactly the same here. And I guess so, 26-degree rotation here, 26-degree rotation here. Okay, it's a little worse, but no one cares. Okay, I think this is good enough. Let's reset our skeleton. There is no distortion here. What we could like just move this skeleton just a little to the left, maybe, so it's more symmetric. So maybe run 5 and then get the skeleton, overwrite the rest pose. And now we can rotate it a little bit. Yeah, I mean, whatever. Not that big of a deal, if I say so myself. But if this does not work out well, this will be hell. There will be hell to pay here, trying to debug all these. Is this how the legs should look like? Don't we have like a right leg polygon separately here? Well, this is actually fine. This one. Oh, because this also moves the pants, not just the leg. So if I rotate this, yeah, these rotations should not affect that sprite. This clothes, pants, yeah, pants. Okay, so pants. No one should have any effect on the pants. The pants should not be affected by the legs and the feet and nothing. The only thing that should affect the pants, I'm not really sure. But anyways, let's remove the legs here and the body and the clothes. Where is my other leg? This hip, it rotates, everything rotates with it. There is no surprise in that. Spine, that doesn't matter. Left shoulder doesn't matter. Right shoulder doesn't matter. Right leg. When we move this leg, so when we move this leg, should it move the pants like this? This looks extremely awkward, and it looks even more awkward when I rotate it, so this like should move the leg, of course, and that moves that, but for the pants, let's have no effect from the skeleton. So how do I remove all the effects from the skeleton? I guess one by one. Left leg, right leg. Okay, now if I'm turning the legs, why are they still affecting the pants? I don't like it. This is not how it should look like. Reset the rest pose. Pants. UV. Oh! Because these were also painted here. I just did not realize because those did not look black. I mean, those points did not look gray. I am sorry. Alright, let's see now. Okay, fine. Okay, so this is good. Reset rest pose. Everyone calm down. Let's save this. And of course, if we take a look at the git diff, polygons have been changed. These are all these lot of numbers here. Some of the positions of the vectors have been changed. More polygon changes. Yeah. Let's add this to our staging area here, and let's finally start working on the animation. So let's add child node animation player. So this is the first thing, and then we'll have an animation tree. We need to create a new animation. Idle. Okay, so I created a new animation here. And I guess if I press S or Ctrl S on the save, and check my status and the git diff, we'll see that there is an idle animation added here and animation player. Alright, so I don't know why I just did that, but whatever. So add track, property track, 3D transform track, call method, Bezier curve, audio playback, animation playback track. What do we need here? Do we need a property track here? I guess. So what I want is a left shoulder bone, a rotation in degrees. Okay. Open. And then we can add the track, or what happens? So this is left shoulder, right? So this is the right arm. So that's a left shoulder. Okay, now it becomes blue if I select this. So if I insert key, create new track for property position and insert key. Create reset tracks, use Bezier curves. I like Bezier curves, I'm not sure if that's the good call here. Create reset tracks. What is a reset track? Animation node. Tutorials using animation tree. That's not what I want. Oh, animation player, that's what I want. I'm sorry. 2D sprite animation, animation tutorial index. 2D skeletons. I already know the skeletons. I already figured this one out. This is what I dealt with in the stream. Like, anyways. The question is, maybe I should just type it into the DuckDuckGo. Reset tracks Godot. How to use reset track animation? Can someone explain what the point of reset track? Sorry for the sudden light mode. Can someone what the point of reset track on new animation player is? It's quite simple actually. The animation player animations change properties. So while you edit or play back your animations in the editor, you might change all kinds of properties throughout your game and therefore the state of your object, scenes and entities. So do changes elsewhere in your project, you probably don't want some weird mix of states, especially before you run the game. This is where the reset track comes in. By resetting your animation to the reset track, everything is in a predictable and desired default state. If you rely on the animation player a lot to change properties, states and execute mechanics, this is really vital. I used to make this reset track myself, adding all properties I changed manually. I also just called it default as a personal preference, but now it's done automatically for me, which is nice. Lol. Well, I definitely still don't get it. Explain like I'm 5. Okay, I was actually just messing around and figured it out. Here's a good example for anyone seeking further explanation, I think. I made a looping animation, start loop, with animation player. Made a play when my character is invincible. Normally without the reset track, if I wanted a case where the looping was playing and another case where this looping wasn't. One solution would be to make a second track called stop loop with the default keyframe only or nothing at all, with loop disabled lasting for at least 1 frame. I would then call in my code to play each of these. Okay, with reset you essentially don't need that stop loop. and the actual makes it for you and calls it reset. No, and I think it was a good explanation. That's hard to explain. If you enable reset when you add a new track, the current value of its property you create the track for is recorded as track and key in the reset animation. So this property stayed before you made any change to animation. Okay, I guess create. And we have position X and position Y. Continuous. Maybe I don't want Bezier curves. Discrete Tigger capture. Nearest linear cubic. Yeah, we can just... and I'm not gonna change the location. Anyways, only the rotation. So I can even turn off the location here. Yeah, maybe this is what I should have done. What is this measured in? Is this measured in seconds? Snap to 0.1 seconds, that's fine. And the animation length, animation looping, yes, animation length, that should be like 5 seconds. Maybe just do nothing for like 1.5 seconds, so let's key it here. And then like move. Oh no, don't do this! This is not good manners. I am sorry, I don't know why I find this so amusing. I shouldn't. I should be ashamed of myself here. Alright. So, yeah, so what we want is a little rotation, maybe just this much, 18 degrees. And let's key. Very good. Okay, so what I want is I want also add this no Bezier curves, just nice cubic interpolation. Very good. Keep it 0, just like that. Keyframe. Move up and maybe rotate just a little, maybe -10, -15 degrees. Yeah, just a little rotation. Key that. And then maybe after like another half second, we get this to be rotated to maybe +16.9. And maybe change this one's rotation a little bit, maybe -7. Let's key these. Oh, it does not insert both. Okay, and then by 3 seconds everything goes back to 0. So let's key this one and let's key this one too. And now I can also add the keyframe here. And now, can I play the animation? Yeah, maybe it's a little too aggressive for like an idle pose to change the rotation, like to move the arms this much. Maybe I could reduce the rotation there just by a little. And yeah, this looks like a lot. Okay, stop. Go back to the keyframe. So this is too much, too fast. What if we make the animation a bit longer. Maybe not 5, but maybe 10 seconds. Time 10. And make these like twice as long, so instead of this last thing, it should be like 4.5 seconds. This one too, 4.5. This one, 3.5. And this one, 2.5. Easing, what is easing? What happens if I change the easing here? So this now does not have to be 10 seconds, 8 seconds is barely, or is rather it's perfectly enough. Is this because it's cubic? But if I do linear interpolation, this will look very like a robot's movement, yeah? You can see the problem with that. When I have the cubic interpolation, this is why maybe using the Bezier curve instead would be better, but Bezier curves, aren't they computationally very intensive? Can I do the easing like, I don't know. Okay, so these have to come back to 8 seconds. Yeah, I guess that is what I need. The easing needs to be, and this one will have to be a big number. No? Does it have to be a small number? What? Yeah, this is definitely not what I want. Just make it 1. Alright. Maybe I just need to add another keyframe here. And 0 keyed. This one also 0 and keyed. Maybe I'll add another keyframe. Okay, I can just key it here. Great. Wait, what? Why isn't this connected? I'm not sure. Okay, this looks very stupid. So this one also has to be 1. Still, the movement is too much, so that is for sure. So at least this one, minus 15, is just too much. No, the shoulder, minus 18, too much, so let's make it minus 9. Let's just make it half of this. This one also, minus 7. And this one, it's in, oh, what? This can be just -3. What is this? This is -9. And then this place is just, let's just make it 9. So now the character just moves its arm a little. You know that the arm moves back still too much. Let's make it just 4. Yeah, I guess fine enough. So let's start animating this one too. Rotation, create, rotation, create. Okay, so we want to add the keyframes here, just like that, just like here too. And then maybe the two arms should not move in sync. So maybe we can shift this by half a second. And then key. So what is the keyframe? What is this keyframe? Minus. So shoulder is -9 and -7. So shoulder is -9. The arm is -7. And then when it goes into the other direction, then this will be like -4. And the shoulder can be 4. Okay. No, not the polygon, I want the shoulder. So 4, key it, 0, key it, this one, arm also 0, and we'll key that, and key it again here. And key it again here. Okay, and now we can change this also to cubic, and we can turn back, dress up quickly. Okay, so now our character in the idle state still showing a little movement, like okay, this I like this. I was thinking maybe I should like make our character also tap their toes. Oops. I don't think that's really necessary. Okay, stop. So the animation player, current animation, idle. So the question is, if I don't do anything else, just start the game. Create a game. So the animation is not playing by itself. So I guess I guess somehow we need to make this animation the default. So maybe cutout animation, or maybe introduce into the animation features. Computer animation relies on keyframes, that's fine. Tip, if you animate the wrong property, you can edit the track's path anytime. Okay, tutorial creating a simple animation. Yay, our animation runs. Back and forth loop. Set the animation length 4 seconds now. Okay. The update mode of the track tells good. Okay, that doesn't catch. Okay, I know this. Keyframes for other properties. Edit keyframes. Using reset tracks, it actually has it. You can set up such as reset default pose. This is used to ensure that your default pose is restored when you save the scene and open it again. Okay, this is cutout animation, stop motion animation. Okay, this is set up the rig. Okay, offset and things like that. Remote transform 2D node. Welcome to the scrolling through documentation stream. So we have the bones. I already do the bones. I have the bones. Okay, animation tips. Following section. Okay, setting keyframes and excluding properties. Yeah, I guess this is fine. Creating a rest pose, we did that. Modifying a rotation only. Keyframing, I key chains. And editing, okay, I don't know what those are. Setting easing curves for multiple keys. To the skeletal deform. Now the only thing I want to know is how the hell am I? String autoplay. The name of the animation to play when the scene loads. Okay, so we have a set current animation. The name of the currently playing animation. If the animation is playing, the properties value is an empty string. Changing this value does not restart the animation. See play for more information on playing animations. Okay. Place the animation with key name. Custom blend times and speed can be set. The animation player keeps track. Okay, so this is actually something we won't be using because we will be using the animation tree instead to do the transitions between the animations. When linked with an animation player, several properties and methods of corresponding animation player will not function as expected. Playback and transitions should be handled using only the animation tree. The animation player node should be used solely for adding, deleting, and editing animations. Okay, so I actually don't really need to know more about this. But for the purpose of this testing, what we can do is root node current animation, reset and save, playback options, process, idle, physics, manual. What does this make? What difference does it make? Anyways, we have the idle animation with the hands waving around a bit and the reset animation. Okay, that's fine, and I guess We can also add, I mean, let's just save this whatever this is. Nicely moving the armors around, very good. And git diff. So okay, so those have been okay. So we only modified the skeleton.tscn, so let's just add this to staging because I am satisfied with the things that I have done up until this point. Let's create a new animation. Animation new. Walk. And walking. Well, we need 2 seconds to walk. I mean, it depends on how much we want to walk. But what we need for walking is legs moving back and forth, both left and right legs. Well, we need to also move the knees. I mean, I guess this would look better if we also move the knees. And we can move the right toe. I mean, it depends on how complicated we want our character to be walking here. Alright, let's just reset our pose here. We definitely want to key. I will just create rest track. Yeah, why not? I will add also the knee. Should I move the foot? I guess moving the foot is actually better than just moving the toe. Okay. So I will key this, and we'll key also this. Leg, knee, foot, what? I said I want to key this. Okay. Cubic, everything is gonna be cubic here. Because cubic interpolation is better than linear. Okay. I'm sorry. So let's take a step here. We start by lifting up the leg 30 degrees. Too much? 25? What? Minus 25. Yeah, maybe this should be enough. Well, we can like modify this later, so that means if we put it back to 20, does it make, like, is it this how people walk? You lift up your leg. But definitely don't start walking by lifting up your leg. You actually start walking by pushing yourself forward with your leg, but I guess it's a computer game. Maybe this should be minus 35. You put down your leg and then what happens? Then you move your leg backwards, I guess. To some degree, maybe like 15 degrees. And then your knee will even turn even more. And this is when the feet. So the feet, of course, stays put. Feet and toes, they don't move. Like, I mean, you could get your feet rotated a little, not your toe. The toe stays, let's leave the toe alone at this point. Let's move the feet. Come on, the feet. Few degrees. Yeah, not that much, just maybe 2. Like 5 degrees. Let's key it. And now this is the pivotal point. When your feet still a little more up, so maybe okay, 12 degrees, that's fine enough. I don't want it to distort the shoe that much. And the toe has to be rotated more. So maybe I could just rotate the toe like a lot. And not the feet. I guess it's a little too much here, right? Because what if I decrease this a little and give this one some additional? Yeah, this is much better, but I don't have a keyframe for this joint over there. And of course this should be keyed at 30. Okay. On this one I'm going to go take 0 up until this point you will be 0. It's kind of fine, I guess. I don't know how well you can see it on the stream, so let's zoom in. Wait. It should be playing it forward. Yeah, this though, why don't I have it at 0 here? Yeah. And then we can key everything at 0 here too. Okay, I don't know what you people think in the chat because no one's writing anything in the chat, which is fine. I mean, you are not obliged to talk to me while watching. But anyways, so something is a little bit fishy at the point when the animation starts. Why is it that? Why does it look weird? Why does it look weird? Oh, I guess because this frame and then this frame is played, so both of the frames are played. What? Yeah, okay, so this looks actually quite nice. I like this. Okay, so, but of course we don't only walk on one of our feet, we need to move both our legs. And I should do the same thing just out of sync. So of course once this leg is down, this is kind of when we should lift our other feet. So let's just create all the necessary keyframes here with 0. And then I'll basically, can I duplicate key? I don't know what I did. Okay, so we have toe and foot and everything. Okay, so this one has to be here. So we need need to lift this is at -35, so I guess we need to leave this at -35 too. And then knee is 20. So we will key the knee at 20. The right foot is at 5. So the left foot should be keyed at 5 too. And nothing is for the toes at the moment. Okay. And then, of course, these points are all 0, which is I guess we can key everything to 0 here for these two, so 0, 0, 0, 0, and 0, I guess. And I have the keyframes of these. Zero, okay. And this so when the legs are up, these legs should be down. And for that, so the right leg's position is at 15. So the left leg here will also be 15. And the right knee's position is 20. What? No, here. Right knee here is, yeah, it's 20. Right foot is at -3, so this foot will also be at -3. Let's key this. Right toe is at -30. Okay, this is right toe 2, right? Right toe 2 is at -30. So left toe 2 will also be at -30 here. And we need left toe 1, which is the right toe 1 is at -18. So -18 here. Okay. What are we looking at now? Why is the toe is rotating, but it does not affect the foot, so there is some problem with the foot here. But anyways, the animation looks fine enough, so I'm gonna save this. And we'll take a look at what is the problem with what foot that is. Left foot, left toe, right, left toe. But these have all the effects they should have. So what's up with the right leg? How is it different? It's actually the same. It is actually the same. Why then? So you can see here the toe. Oh, maybe this left toe is not. Okay, so the left toe is missing. Oh, the left toe is missing a keyframe here. Left toe 1. So right toe 1 is at -18. So let's play this again. Yeah, I think this is fine. I mean, maybe we can argue that maybe the left leg we shouldn't like make it a little more subtle. Maybe lift it less up than the right. And maybe the right leg should not go that much backwards. But those are fine-tuning things that maybe people who are actually good at this can help us with. So first, here I just want to make things work. Maybe the sprites will have to be a little more fine-tuned to like how this little rectangle here is visible. Okay, so this is fine. So now we are walking with our legs. And I will just add everything here. But we also need to walk with our hands, which by which what I mean is that our arms should be moving while we are walking. Which should be like very similar to what we did with the idle animation, but in this case it should be like in the idle animation what we do is just stand there and just move our hands a little bit and then just stop moving. So this is the idle animation. In the walking animation, these joints okay, so reset, yeah. This is interesting. So this is what reset animation is for, because you can see like I was testing, I played the idle animation and it like the arms are moved, and now I moved to the walk animation. The walk animation does not have tracks for the arms yet, so it just keeps it like that. So I go to reset. Very, very nice. Alright, walk. Let's get back to walking. So when my left leg is up, how do we walk? How do I walk? Do I walk when I lift my left leg, I guess my hands go back and then I go forward. Okay, I don't know. Maybe my walk is weird. Maybe I walk in a weird way. I'm not sure. But anyways, so when the legs are up, the arm should be backwards. Maybe 24 degrees, reasonable. We already have a reset track for this, but whatever you say, Godot, whatever you say. And then when our left leg is down, we can go back to 0 with these. Did we key both? Okay, so this is getting out of hand. We definitely need to key these to 0 at the beginning too. And then as we move forward, oh, I see. So the left, okay, so this one is not cubic. So that was the problem. These are the left foot or left legs were cubically interpolated instead, or linearly interpolated instead of cubically, which is not good. I don't like that. Okay, so now we can move our hands, and if we are not Russian special agents, we move okay, so actually forward, this is a nice forward position for the arm, and maybe the knee, not knee, what is it, elbow. Yeah, a little, just not that much, just a little, 12 degrees, looking great. And then it goes back. Okay, so let's animate. I think it's reasonable, it's acceptable, it's good enough. Okay, why cannot I just stop this by pressing the space bar? Okay, this one, let's key it at 0. This one we're also going to key at 0. And as we move forward, let's key this one, let's key the arm, and then at 1 second we go back to 0 degrees. And even though we don't see it, we're still going to add the animation because it affects how things look. So let's animate. Do we also want our hip to go up and down a bit in sync with this? I mean, I know like Among Us, which is I guess the standard for social deduction games, is like having a really like a nice like a bumpy, I don't know what I'm trying to achieve here with these reenactments. So it has like a very bumpy motion, so maybe we should like have like this up down motion for the hip. Can I? Okay, let me just stop this, reset, save, and git add, because I am very satisfied with what's going on at the moment. And well, I don't want to lose the progress. Okay, why? What's up with this toe? Why are you minus 10? Yeah. This is not correct. Skeleton. Go back to rest pose. And we need to overwrite this. Okay, so now idle. So the idle has, okay, so the idle moved our arms a bit. The arms move around a little. Okay, now I go to walk, and the walk, this just moved everything. So now I stop, go to reset. Okay, good. Alright, so we walk with our legs and with our arms. Okay, there is another, this one also has to be cubic cubic. Okay, so let's add some animation to the hip. Should we rotate while we walk? Do some parkour? No, I don't think so. But if we key the Y position, let's go back to 0 here. We can add a little subtlety to the things, I think. And people can correct me in the chat if I'm wrong, but we can just say 0, create the reset track, of course. Oh, but I don't want the rotation. Can I trash this? Okay. I want the position. And I want the position to be also cubically interpolated. And well, I guess if the walk cycle is 10 seconds, then maybe I can. So this is the point when the hip goes up, and then this is the other point when the hip goes up. So maybe this is not where the 0 should be, but let's consider that later. So here I can add a new, like maybe I want to, hello, welcome to the chat. -10, lift this guy up a little. Huh? No, why don't we, I said lift this guy up. -10. Why can't I add the, oh, okay, that's there. Goes up. Okay, how should I move this guy up and down? Should go down? No. Maybe this is the point when the guy should be like highest position here. And maybe this is actually like, maybe this was not a stupid idea. Or rather, I have no idea what I'm talking about. Okay, so here -10 keyframe. Okay, so now let's take a look at how our guy walks. Guy walker. What's up with the pants staying down here? Why is, like, as he's moving up and down, the pants stayed down? What the heck is going on over there? Okay, I need this. This is good, but I will double this motion. So -20. Let's see. And leave a like on this video if you like how the guy walks. It's quite nice. It's a little slow, I think. Maybe we can speed this up. Animation length. So we could speed this up considerably. I mean, it's not bad. It feels a little slow, but that's not the problem. The problem is What's up with the pants? So why are the pants... why are the... like your butt stays down? What's going on here? And that is pants. What's up with the pants? Is it the UV? Maybe that's what I need to do is... okay, what I need to do is save. Okay, no, you go back to reset mode. Now save. Now let's go back to walk mode and let's see. Why are your pants bottom staying down? So because if I take, so the problem I see here is that points and UV are just not the same. But is that an issue? So let's go and see all. Okay, so the hip does not affect. So no, okay. What happened? I clicked outside. I'm just gonna make everything white here, so all these points make them white. Hip, spine, nothing, spine to neck, head, left shoulder, arm, left hand, right shoulder, right arm, hand, whatever, and nothing else affects this. Let's go back to... okay, now it's good. Now your pants move up and down as you walk. It's a very casual, very slow, slow moving walk. But I think in general, like, the animation is fine. It's nice. I'm gonna speed this up a bit before moving forward, I guess. And then we can start to figure out how the heck we can work this in to the game. Okay, let's stop. Let's go back. Let's can I just like select all of these? Great, and let's move them to 0.3. And these ones will be moved to 0.6. I'm gonna move all of these to 0.9. These ones I guess we can delete. And we can make the whole animation 1.2 seconds. So let's see. Yeah, what a nice casual walk. I think it's good. I really like this. I like this animation. So how do I stop it? Here. Let's go back to reset. Let's save this, and I will git commit -m idle and walking animations added. Great. Very good. So now that we've done that, now comes the other part I have no idea about, and that is, of course, the animation tree, a node to be used for advanced animation transitions. And now we have an animation tree here. And now let's go back to our favorite thing, reading documentation on a live stream. Okay. So, in the meantime, I have to check my messages, which I am doing, but animation tree thing needs to be solved here. Node to be used for advanced animation transitions. Okay, that is very good. Tutorials. Let's see, with Animation Player, Godot has one of the most flexible animation systems. Okay, very good. Thank you for your compliment of yourself. Thing that you can find in any game engine. The ability to animate almost any property in any node or resource, as well as having dedicated transform, Bezier function calling. Okay. However, animation tree, before starting, let's make clear that an animation tree node does not contain its own animations, Instead, it uses animations contained in an animation player node. This way you can edit your animations as usual and then use this extra node to control the playback. Very smart. Most common way to use animation tree is in a 3D scene. When importing your scenes from a 3D exchange format, they will usually come with animations built in, either multiple or one split from a large and one. Okay. An imported Godot scene will contain animations and okay. As you rarely use imported scenes directly in Godot, you can place the animation tree node in your new scene which contains the imported one. Afterwards, point the animation tree node to the animation player that was created in the imported scene. Okay, now this is how it's done. Animation tree, anim player is anim player. Okay. Ta-da! Then we turn on active, I guess. No, we cannot turn on active at this point. A root motion process. Should we do this during physics? I guess maybe we can. Process mode physics. Process notification in which to update animations. I'm not sure which one is the correct one, but this screenshot has physics selected in here. New scene was created from, okay, creating a tree. There are three main types of nodes that can be used in animation tree. Animation nodes which reference an animation from the linked animation tree. Okay. I guess it means linked animation player because we are in the animation tree. Animation root nodes which are used to blend subnodes. Okay, and animation blend nodes which are used within animation blend node tree as a single graph bending via multiple input ports. What? Welcome to the chat, Dragan Moich. Is that Serbian or Croatian name? Sounds like a what is it called? Like a Southern Slavic? Is this your first time watching my stream? Serbian, yeah, okay. I guess I am good at guessing things. So welcome to the stream. Welcome to the OpenSuspect stream. So if it's your first time here, let me show you today's progress. I made this animation for my characters to walk. Oh no, this is not what I wanted to do. I started the game instead of playing the animation. How silly of me. Okay, so walk animation. So this is how the characters will be walking in the game. Once I figure out how to do the animation tree. But I will show you the game because it's your first time, so quick intro to the game. OpenSuspect. We have many characters. We have a variety of characters. Not everything is finalized yet, I guess. Faceware. Let's remove the glasses so you can actually see the different types of faces here. Mouth. You can have different mouth. Facial hair. Hat or hair. This is actually modeled after an Eastern German police uniform, because this game is like a spy game. It's supposed to be a social deduction game playing in East Germany, and everything is in Godot. Currently, okay, so you don't have a hair. Why do you? You should have hair. Okay. You can change. Like I know, like. East Germany was not that racially diverse, but still, you can, in this game, you can be whatever you want, I guess. This should be the background of the game, and not much, it's still pre-alpha. So this is the lobby, this should be the game lobby, a train, and we only have one map planned out, so you can, okay, so I'm just started alone, so there's not much we can do here. This is a laboratory of the East German state security. This should be our first map. Not much you can do here. You can go through gas cabinets, for example, but you can open gas valves. And now you can increase the pressure in the tubes. Things like that. You can open cabinets. And pick out chemicals, and nothing, you cannot do anything with the chemicals just yet. But that should be the concept of the game. A social deduction game in the 1950s, 60s, East Germany. And so now I'm working on having character animations. That's the short description of what we are seeing here. So I'm trying to figure out how to use the animation tree to actually like play the animation of the idle animation. So when the character is just staying around, they just flail their hands idly, I guess. But when they walk, they should walk like this. So this is what I need to implement in Godot using the animation tree somehow. But I've never done it, so it's time for me to figure it out. So what I need to do is, I guess we need to do something here. Tree root. Oh, we need a tree root. Okay, so what type of tree root should I have? Animation node animation. Select an animation from the list and place it. This is the simplest root node and generally not used directly as root. Okay. Animation blend tree contains many blend type nodes such as mix, blend 2, blend 3, one shot, etc, etc. This is most commonly used roots. Contain multiple root nodes as children in a graph. Each node is used as a state and provides multiple functions to alternate between states. Animation node blend space 2D allows placing root nodes In a 2D blend space, control the blend position in 2D to mix between multiple animations. Blend tree. An animation blend tree can contain both root and regular nodes used for blending. Nodes can be added to the graph from the menu. All blend trees contain an output node by default, and something has to be connected to it in order for the animations to play. Easiest way to test this functionality is connect animation node to it directly. We'll simply play back the animation. Make sure that animation tree is active for something actually to happen. So this is what I need to make here for my idle and walk animations. And of course we will have more animations because we need animation for I guess when the character is dying. When the character dies, the character should, like, I don't know, lay down in the on the map. So maybe we need to do the blend tree. State machine. What is the state machine? Is there like a some screenshots here? Okay, so state machine, this looks good. This node acts as a state machine with root nodes as states. Root nodes can be created and connected via lines. States are connected via transitions, which are connections with special properties. Transitions are unidirectional, but two can be used to connect in both directions. There are many types of transition. Intermediate, sync, and transitions can also have a few properties. Click any transition and it will be displayed in the inspector doc. So is this what I need, or is this what I need? Is the blend... So, okay, the easiest way to test this animation directly will simply play back the animation. Okay. Yeah, I think the state machine looks better for me. For this situation here. Excuse me. Tree root, state machine. Animation tree is inactive. Activate to enable playback. Check node warnings if activation fails. Okay, so this is active now. Add animation idle. Add animation walk. And we could add even a blend tree or blend space. How should this work? Play mode, travel, immediate. Connect nodes. Okay, so we can connect them both ways. Transition sync. Transition sync, yeah. Can I play this? Okay, so it's playing. Yeah, this is not... Okay, this is stupid. I mean... Stop. Because now the legs, they just stay however they were before. So maybe I need to add the reset animation here first. at end. And this one can be oh wait, so yeah, this needs to be sync. What? I don't know what is happening here. So if I transition sync from idle to walk, then from walk, and what I want is at end, move to reset, and then immediately to idle. Transition sync. And if yeah, this looks so what I'm curious about is when the arms are actually like moving around, and I start, it's like with the reset, it waits until the walk cycle ends. The sync is a little weird for me. What is this thing to tell me about that? Controlling from code. Where is the state machine? Where was the state machine? Is the ability to travel. The graph can be instructed to grow from current state to another state while visiting all the intermediate ones. This is done via the A-star algorithm in the absence of any viable set of transitions starting at the current state. The graph teleports to the destination state. Okay. State machine first. Let's go back here. There are many types of transitions. We'll switch to the next state immediately. The current state will end and blend into the beginning of the new one. Sync will switch to the next state immediately, but will seek the new state to the playback position of the old state. Oh, that is kind of time-based and not... Anyways, we'll wait for current state to play back to the end and then switch to the beginning of the next state animation. Can we... Okay, so we can... The transitions can have some properties. Click any transition that will be displayed in the inspector dock. Fade time, priority. Oh, okay, this is nice. So I can just do immediate. Everything can be immediate here. And instead what I can do is I can do a fade time of like, I don't know, 5. Fade time of like 0.3 or something. Play mode travel. That's good. Okay, it's much more natural looking. So when the hands are like flailing around and I click on the walk here, yeah, it blends much more smoothly, and I go to reset. Yeah, it looks very good. This is nice. This is really nice. Now the only thing I need to figure out is how to tell the animation tree. Root motion track. What does it? What is track? The path to the animation track used for root motion. Paths must be... Oh, thank you. And thanks for joining the stream. I hope you come back. You can find me on... you can find all my other things in the description if you want to read about the game, you want to contribute. You can find everything over there. And I hope to see you around in my streams. Okay. Path for the end. Okay, so this is all good. What if I play the walk here and I start doing any other things? Okay, that's fine. So animation reset, and that's it. So what I need to do is filter, so switch modes, transition type, X fade time, priorities is together with travel function from code. Lower priority transitions are preferred when traveling through the tree. When working with 3D animations, a popular technique for animators to use the root skeleton bone to give motion to the rest of the skeleton. This allows animating characters and wave or steps actually may match the floor below. It also allows precise interaction with objects during... Okay. When playing back the animation in Godot, it is possible to select this bone as root motion track. Doing so will cancel the bone transformation visually. Afterwards, the actual motion can be retrieved via the animation tree API as a transform. This can be fed to functions such as kinematic body move and slide to control the character movement. This is actually very interesting. If we could do this, that would be nice. Because that would also make things complicated. So anyways. After building the tree and previewing it, the only question remaining is how is it all connected from code? Keep in mind that the animation nodes are just resources and as such they are shared between all instances using them. Setting values in the nodes directly will affect all instances of the scene that uses this animation tree. This is generally undesirable but does have some cool use cases, e.g. you can copy and paste parts of your animation tree, reuse nodes with a complex layout, different animation trees. Okay. The actual animation data is contained in the animation tree node and is accessed via properties. Check the parameters section of the animation tree node to see all parameters that can be modified in real time. This is handy because it makes it possible to animate them from an animation player or even the animation tree itself, allowing the realization of very complex animation logic. To modify these values from code, the property path must be obtained. This is done either by hovering the mouse over any of these parameters, which allows setting them or reading them. Okay, that is not something I want to do. That is not something I want to do because I don't need to do that. So animation tree, so if I just wanted to like change things here, I could check the animation. So this auto advance, turn on a transition automatically when this state is reached. This works best with switch mode at end. Auto advance. Turn on a transition automatically when this state is reached. Which state? Is it for the reset state? Animation node state machine transition. Okay. Anyways, let's save this. What I need to do is travel the state machine. One of the nice features of Godot's state machine implementation is the ability to travel. The graph can be instructed to go from the current state to another one. Okay, so this is what I just read. Var state machine equals anim3 parameters / playback. To use the travel ability, you should first retrieve the animation node state machine playback object from the animation tree node. It is exported as a property. Once retrieved, it can be used by calling one of the many functions it offers. The state machine must be running before you can travel. Make sure to either call start or choose a node to autoplay on load. So I can choose a node to autoplay on load. Okay, so let's take idle. Toggle autoplay this animation on start, restart, or seek to 0. Set the end animation. This is useful for sub-transitions. I don't know what that means. But the question I have now is if I start the game, will we have... Yes, we have the animation by itself. So the animation is actually playing. You can see like the hands flailing around a bit. Okay, this is very good. I like that. Now, I think this should be in the skeleton, I guess. This is the accepted file extensions to PNG, directory of color maps, items in hand, on ready war, variable hand node, color shaders. Okay, so what do we need here? These are public variables. We should state these are public variables, which we forgot to do. Public variables. And among these public variables, we'll have the, I guess, is this also an onReady variable which we should have? I guess so. OnReady var animation tree equals animation player / animation tree, and also OnReady var state machine, which is animation state machine playback. And that is supposed to be anim3 parameters / playback. Well, I guess this is what we named it. And so once that is done, we can say state underscore machine.travel. I mean, this is what the state machine.travel. State machine must be running, yeah. So we just need the .travel parameter there. So I guess we have oh, we don't really have much here, so we cannot control this from the skeleton. We need to control it from the character. So skeleton will just have these, and we can access those from the character. I guess we need to have like a skeleton node. Remember, skeleton already exists in a parent class. Oh, I'm sorry. I always forget that this is coming from the entity. So yeah, we have the skeleton here. And the entity, okay, so it's not the skeleton, it will be the entity most probably, right? Which set look direction, set position, set movement parameters, move command. Calculate the actual motion, acceleration times delta. Yeah, I guess this is where we can actually say skeleton dot what is it? What did I name it? State machine dot travel and so this is going to be, so the travel is that like, yes, lowercase, and this will be called walk, and then that will be called idle. Is this going to work? Yes. Yes, this works. Great, looks really good. Yeah, I like this. I will have to share this in the Matrix chat as soon as possible. Okay, I think this works. I think we can consider this working, and I mean, we will have to have more animations, so this of course will not be made into a PR just now. Because first of all, let's face it, if there was going to be a problem once I start playing this in multiplayer. So let's go back to lobby. Let's run the games. Let's put these two next to each other so I can demonstrate you exactly what I'm talking about. So you see, I'm only like when I move my own character, the animations play. Of course, the other instance does not know anything about anything. So I guess that's a problem. And of course this, okay, so yeah, this is bad. The camera is broken here, but you can see that the character is not animated. Well, I mean, the idle animation is played even when it's moving. So we need to revamp how movement is synchronized between the client and the server and the other clients for everything to work nicely. So excuse me. That is what it is. What will have to be done next. We'll also have to have an animation for the character to die, because now I shoot the character and it just like turns like 90 degrees with without any subtlety. We will deal with that, of course, later. Now, today's stream is over. I've already spent 2.5 hours with you working on this. So let's close Godot. Let's git add. Let's just see the difference. So git status skeleton gd, skeleton dsn, and gd. So what is the git diff here? Well, I guess we added the animation tree and all the related things. Not much, but very important stuff. So git add everything, git commit -m walking animation plays for main character, and git push origin character animation. So anyone who wants to check this out and wants to contribute, it is on my GitHub as soon as this push finishes. Okay, so my GitHub nice micro character animation. You will find this if you want to, I guess, check this out, want to contribute, want to refine the animation, maybe want to add the animation for the character being dead, stuff like that, if you want to help out. But the thing is, anything you do, before you do anything, join us in the Matrix channel. You can find our Matrix information down in my YouTube video description. So I guess that is it for today. Thank you for watching, and leave a like on this video and subscribe for more content if you enjoyed what you've seen. All right.